So, C programming. In our last video, we discussed about the basic structure. Okay. Of C. Okay, we discuss about the data types. We discuss about the conditional statement, which are if, else, okay, and switch. So now what we are going to cover, we are just going to discuss about what is loop. So loop is what? Where you are going to loop. Okay, what is the requirement of loop, and this type of stuff we are going to discuss. So what actually loop is? Very simple line. When you want to execute a single statement multiple times, then you are going to use for loop. For loop, while loop, whatever loop we are having. So when you want to execute a single statement multiple times, then you are going to use the loops. So all the programming languages provide us multiple types of loop. Very common loops are for loop and while. So what is for loop? In for loop, like if you are talking about the structure of this for loop, so what we are having? We are having the structure like for. Then we'll have initialization that can most of the times done in this way: I equals to 0, semicolon. That section is known as the initialization, that you are just going to init. Okay, initialize your block. Then we'll have a terminating point, that where this loop will going to terminate. For example, I'll just put that loop will going to terminate at 10. Like once that number reach, that I means index, reach to 10, so that can be terminated. Second is increment or decrement. That is based on the requirement, whatever we are having. So this is our condition. Okay, that is a terminating condition. And then increment or decrement, whatever we have. So this is your condition. So in this way, you can run your loop. So just keep one thing in mind: whatever variable you are going to use, that either you can initialize in this block, or you can initialize where you are using the data type and other stuff. So how you can use the for loop? Hash include stdio.h. I'm just going to create a very basic program which will going to explain you about this structure, the loop structure. Now main function. Okay. Now see, as I tell you, we'll have a for loop. So let me initialize integer I equals to 1, semicolon, I should be less than 10, semicolon, I plus plus. So there my loop will going to initialize from 1, and that will terminate at 9. Okay, with increment at by 1. Okay, that will going to increment by 1. So printf percentile d, comma, ampersand of I. Now if I'm going to run this, once again, let me type /m. Now if I'm just going to run this code, so what I'm going to get as an output? Okay. Oh, 1 second, guys. We are not scanning. The ampersand is used for scanning. So this is the output. It starts from 1, and that will going to end at 9. So what you can do, if you are just going to put that equals to, right? So what you will get? You will get number from 1 to 10. This is a very simple structure of for. Now what you can do, like if someone tell you, you need to print a table. Okay, so what is table? Table of 2. So what we'll have in this table, guys? The table is just like 2 into 1, 2 multiplied by 1 equals to 2. Okay, then 2 multiplied by 2 equals to 4, and so on. So if you notice that, so what we are having, we are just going to execute a single statement multiple times. What is the single statement? We are just going to multiply that with, see, the number is changed. Of course, number will going to change, but you are just going to deploy that one time and you will get your output. Now, if I'm going to run this code, so what I'll get? Table of 2. Now, someone said you that you need to perform this as a user input. No problem in that case. What you can do, you can initialize a number. This should be the correct location. Integer number, semicolon. Now, scanf, that is used for user input, percentile d, comma, 10% of NUN. And you can give a message, please enter your number. Please enter your number. So that user knows that what operation they are going to perform. Looks fine. Now let me run this code. This is my console. Okay, that console is loading. 1 second. All right, that looks fine. Okay, that is taking time. 1 second, let me stop this. See, because that is a cloud-based compiler. Okay, now enter a number. Then I entered 3. So I'll get my output. 1 second. Okay, I had not performed changes there, guys. Number. This will be the complete program. You can see. This is the complete program. Now, if I'm just going to run that. Okay, that compiler is creating issue. So number is 4. So you'll get the table of 4. That's it. This is the way that how you can use the for loop. Okay, like some people say we'll have, see, you can use any type of structure. Like if you don't want to declare here, what actually for loop required? Only 2 semicolons. Okay, you can put it there. You can remove this I++ and you can perform this I++ here even. I++ semicolon. Oh, sorry. Let me run this code. Okay, so that is not support. Oh, 1 second. 1 second, guys. All right, so we are just going to input a number 4 and we'll get the same. So what actually for loop required? See, the same thing it required. We'll have initialization there. Increment, decrement is there, but see, condition should be comes in between this block. Okay, this is known as for loop. Now, what is while loop? So while loop is like, see, the same structure which we are having. Now, what changes you are going to do? Things seems fine. Let me convert this for to while. And the only change is just remove these 2 semicolons. The rest of the things remain same. Let me show you the output first. Okay, it is asking for the number. I'm just going to provide number 5. We'll get this output. So what changes? See, if you notice the changes are while. Here we'll have a condition. Okay, again, condition is there. Whatever condition you are using, that is inside this block. And inside this block, whatever you are doing, like increment or decrement, whatever you are doing, if increment, so increment you can perform there. And this condition should be initialized here, just above the while block. Anywhere, like, but once the condition will enter to the while block, that should be initialized. Okay, otherwise that will jump to infinite. Like, see, if you don't have this initialization condition, okay, so, and you are not going to perform anything like increment or decrement, so that will jump to infinite. One common structure, guys, never put semicolon after the while loop or the for loop anywhere. Otherwise, your program will terminate at this line. Where you did not put semicolon, see there, like when, so while loop is completed. When you know, see, from this scope, any line which you write, this line, never have semicolon. Okay, no, that is not at all suggestible. If you are going to write semicolon over there, that is not suggestible, big cross. Okay, so you cannot use semicolon here. All right. Rest is like where we cannot have semicolon. After if, for, while. In these blocks, we cannot have semicolon. Right. Don't put semicolon after that. So this is the for loop and while. All right. Now we'll have the next concepts, just known as array. Okay. So what is array? But before that, like before jumping to array, let us discuss some basic program like sum of digits. Okay, you'll have some digits, how you are going to perform the sum. So, like for example, user gives you some program which is 1, 2, 3. Okay, you need to perform the sum. Sum is 6. We know that sum is 6. But how you are going to perform this? How you are going to perform the sum of these three numbers? So, like if someone tells you you need to perform the sum, so what you are going to do? First step, divide by 10. Mod by 10. You will get 3. Now you need to reduce this number, divide this number by 10. Now the new number will be 12. After that, you are going to repeat this until and unless the number will not become 0. So 1, 2, 3, done. Now 1, 2 mod 10. What will get? Guys, 2. Okay, now 12 going to divide by 10 again. So what will get? 1. Now the same operation, 1 mod 10. Okay, we'll get 1. Now you can add this 1, this 2, and this 3. So you will get your output. But how we are going to do this practically? Okay, so to implement this, please enter a number. That seems fine. Okay, now when you are going to perform this, that's what you need to understand. Until and unless your number is greater than 0, okay, you are going to perform this line. See, let me tell you one thing. What is my style of, how I'm just going to create a program? What is my style of programming? I don't know which variable we required at initial stages for those basic programs, right? So what you can do, you can just go with some variable. And if you're writing them anywhere in the notebook anywhere, so don't put the semicolon. Leave the semicolon as it is. If this will be the last variable, so we can use that there semicolon. Otherwise, we can move forward with the comma. All right. So now while number is greater than 0, now we require somewhere where we can store the respective result. So let me take or remainder. So let me declare this variable as a rem. So there what I'm going to do, remainder equals to number mod 10 semicolon. So what we'll get in that, in this we are going to get the remainder like 3 in case of 1, 2, 3, 2 and 1. After that we can add them. But how we are going to add them? That we are going to check. Okay. Now remainder seems fine. Next, what we are having, we need to reduce this number. So what you can do, you can type number equals to number divide by 10. This line. See, first we write this line. Now we write this line. Okay. Seems fine. But let me take one variable where I can store my result. So as we are going to perform the addition, so we can declare that number with 0 itself. Reverse equals to 0. Okay, what is the benefit of this? Now let me put reverse equals to reverse plus remainder. Why? Because programming comes in this way, right to left. So what is the initial value of this remainder that we are going to check, the result, everything we are going to check. Now we'll have this printf percentile d. Okay, guys, we are not going to put this inside a loop. If you are going to put this inside a loop, so you will get the output multiple times. So let me print this printf result outside the block. Okay, this result. So that is sum equals to this. Looks fine. Now let me check this. Okay, now if I'm going to run this code, let me scroll this up. Entire number. If I entered 1, 2, 3, so I'll get sum equals to 6. Works fine. Let me run this code again. If I'm going to enter 2, 3, 4, sum is 9. Works fine. Okay. Now how this program is working, guys. So initially, what is the value of my number? I entered a number which is 1, 2, 3. Let me go with this 1, 2, 3. That is 1, 2, 3. Now program comes to this section, which is the while loop. Now, is 1, 2, 3 is greater than 0? Of course. So please move forward. See, I'm writing this in comment. Now remainder equals to, what should be the value of remainder in first pass? Remainder equals to 1, 2, 3 mod 10 that I explained in the notepad already. So which is 3. Now, see, I need to reduce a number. So number equals to 1, 2, 3 divided by 10. So what I'll get? Number equals to 12. All right. Now, what is the value of result? So result equals to, as I tell you, programming works in this way, like right to left. So result equals to, what is the initial value of result? That is 0, which we declared already. And in remainder, we'll have 3. Looks fine. Now, what is the value of number? 12. Is still 12 is greater than 0? Yes. So what should be the value of the next remainder? In this case, remainder become 12 mod 10. That will gives you 2. Looks fine. Okay. Now, what is the value of number? Number equals to 12 divided by 10. So what we'll get? 1 there. And what should be the value of result? So result equals to 3 is already in this result variable. So 3 plus what is the new variable? That is 2. It means the sum is 5. Okay. Again, number is greater than 0, of course, because number is 1. Right. So 1 mod 10, sorry. 1 mod 10 equals to 1. Perfect. 1 divided by 10. Because we are using integer, so we'll get 0. And thus, in this case, result equals to 5 plus 1, which is 6. If you want to check this, so what you can do, you can print this inside the while loop so that you will get your output step by step. So enter your number 1, 2, 3. We'll get sum equals to 3 initially, then 5, then 6. Let me print this with slash n. It's slash n. All right. 1, 2, 3. What we are getting? Sum equals to 3, 5, 6. See. Initially sum is 3, then 5, then 6. Works for me. You can check this for any. Okay. This is how you can perform the sum of digit. Now, reverse. Someone tell you you need to program to reverse of a number. So how you are going to reverse that? Nothing much we require. What we are going to do, we are just going to multiply this by 10 at set. So what it does do? See, initially 0 multiplied by 10. So what we'll get? Nothing. Output remains 3. But at this step, 3 multiplied by 10. So what should be the output? In this case, 32. In next phase, see, because that will become 32 now. So 32 multiplied by 10 plus 1. So what will get? 3, 2, 1. It will going to show me the reverse. So let me print this outside the loop. Getup is required in the program. Now let me run this entire number. So I entered 1, 2, 3. What I'll get as an output? Okay, that is not a sum. That is reverse. So 258, we'll get 85. This is the reverse of a number. So in this for loop, while loop, we'll have multiple programs. Like if you are going to discuss about the structure of the for loop, while loop, so we'll have multiple programs in that. Like see, we'll have something which is known as the Fibonacci series. So what is that Fibonacci series? That series is something where you'll see you're going to input this 0 and 1, and what you will get as an output? 0 plus 1 equals to 1, 1 plus 1 equals to 2, 1 plus 2 equals to 3, 2 plus 3 equals to 5, 5, 5 plus 3 equals to 8, 8 plus 3 equals to 13 in this way. So there, if you notice, so what we are doing, guys, this line, see, we are just executing a single statement multiple times. It means we require a loop. Whenever you think that you are going to perform that type of stuff, where you want to execute a single statement multiple times, so there you require this type of a structure. So how you are going to make this program? Okay, so this is the complete program which we created for, see, this is the reverse of our number. Okay, and this should be the, like, if you are not going to multiply that with 10, this will be the sum of digit. Okay, now we are going to create a Fibonacci series. So how we are going to create that Fibonacci series? Looks fine. Okay, now see, user has already gives you these two input. So that two input you can initialize at your end. Integer a comma b semicolon, and there you can initialize this a equals to 0 and b equals to 1. That works for me. Okay, semicolon, no problem. I'll just put semicolon. Now what we are going to do, we are just going to print f percentile d comma, sorry, not comma, there, a comma b. So we'll get the 0 plus 1. Okay, looks fine. Okay, I don't want any space there, right? Looks fine. Now what we require them to add recursively. Okay, like we just need to add this 0 plus 1. Okay, then the next way, in this way we are going to add. So how we can do this? So you need to understand the flow. See, this is 0 plus 1. Okay, now you are just going to add this 1 plus 1, then 1 plus 2, then 2 plus 3. Okay, then 3 plus 5, then 5 plus 8, then 8 plus 30. So if you'll notice one thing, what we're getting as a sum, 1. Okay, there we'll get sum as a 2, as a 3. All right, then as a 5. Okay, as a 8, as a 13, and so on. So if you'll notice one thing, so what actually we are doing, guys, this 1 is coming there, this 1 is coming here. Now this 1 is coming, replacing this. This 2 is replacing here. Now this 2 is here. This 3 is here. Again, this 3 is here, 5 is here. So see, this will be an arrow. Like if you notice, this will be the arrow which we are having. So what actually they are doing? They are just transferring the respective values. How? If you initialize this, like we initialize this as a, this as a B. So let me declare this as a C. So C is what? C equals to A plus B. But at every step, see, we are just transferring the value of B to A and C to B. This is the overall concept. That you are just putting A equals to B and B equals to C recursively. So you can ask user that how many times you want to perform that. Initially, I'm going with a simple approach with user defined value like I is less than 6 semicolon I plus plus. And there we'll have C equals to A plus B, guys. Now if I'm just going to printf percentile D C, so what I'll get, let me show you. In this case, that will shows me the sum of A plus B as, like, see, first it will going to print 0 and 1. After that, it will going to print this value. So let me give a space. /n, and there as well /n. So that we'll get like output. So what is the output? This is the, once again, we have error. C is not declared, guys. Let me initialize. Okay, so we'll get this output 0 and 1. This should be A and B. This is C 1, 2, 3, 4, 5, 6. So C is printed 6 times. Now what you can do? Just after printing the C, you can just put A equals to B and then B equals to C. Now let me run this code. So what we are getting? 0, 1, 0 plus 1, 1, 1 plus 1, 2, 1 plus 2, 3, 3 plus 5, 8 in this way. So this is our complete series. Like see, recurse, we are performing the same operation, but that we are just performing n number of times. This is the benefit of working with loops. So what we discuss in this session, we discuss about the for loop and the while loop and some programs related to this for and while. Right? That's it, guys. Thank you.